Jill Hurston, Marketing Director at Synerzip. Welcome to our webinar today. I'd like to introduce our moderator today, Vinayak Joglekar. He is our CTO and co-founder of Synerzip, and he heads our development center in Pune, India. Vinayak, over to you.
Thank you, Jill. And today we are going to talk about service mesh comparisons, SMESH comps for short. And we are lucky to have Bruce Basil Mathews to present this topic. And I've heard him before, so he's really good. And can we advance one slide? So I'll just introduce him quickly. So Bruce Basil Mathews is the senior solutions architect at Mirantis, and as I already mentioned, he is very passionately involved in this service mesh, and he's probably the best person to talk about service mesh comparisons. But on a broader side of his skill set, he also comes from theater background, and it's a coincidence that we have him today on Shakespeare's birthday. So we are lucky to have this presentation. It's a coincidence, so it's going to be very interesting. And I've heard him before in front of live audience. He really keeps the audience engaged, and you can see that he has that knack which comes from his background in acting. So welcome, Bruce, and I'll talk a little bit advancing to the next slide about the topic. So Bruce, we and many of us in the audience, we are new to this concept of service mesh. So we'd like to know a little bit from you on the introductory side, and then we're also, kind of curious what's happening in the service mesh wars, so to say. So you have biggies like Istio and Envoy, and on the other side you have Linkerd and so many of them. And right now we are spoiled for choice, if you ask me. And I have tried my own hand at 1.0 of Istio, and it's still not very clear to me which way the things are going to go. So it will be very interesting for us to get in at this point of time to get your expert view of this. So over to you, Bruce.
Vinayak, thank you so very much for your kind words. And yes, having come from an acting background, it helps me to do these presentations, hopefully. As Vinayak said, today is officially Shakespeare's birthday, the 23rd of April. That makes him 456 years old today. But having run around with him as a kid when we were growing up, I can tell you he doesn't look a day over 300. In any case, today's topic is really one that's near and dear to my heart. It's about service meshing. And there are many different aspects of containerized computing and microservices that are in the phase of development in our country. And some of those technologies involve sort of microservice application layer experimentation. What service meshes bring to the table is the ability to communicate between those services in a hopefully secured, safe, reliable way that helps to standardize how things are going from one aspect of your application service to the next within this microservice architecture. When we talk about a service mesh itself, it has some key capabilities built in. This is what establishes the category, I guess, of service meshing sitting on top of clusters such as Kubernetes or even Mesos. One is service discovery, and that lets you to figure out things like your DNS capabilities, which load balancers you have access to, all of the things within the Kubernetes framework that assist the application developer without the application having to be hard-coded to take advantage of them. As I indicated, load balancing is a big part of that. It means that your application services can scale as on demand. So as a new instance of a particular service comes into play, it immediately discovers where in the load balancing schema it's supposed to be, and the traffic gets balanced automatically, all of those kinds of things through a service mesh. And of course, it wouldn't be complete without having end-to-end encryption, meaning to say that from the moment it enters the cluster, you have a secured way of communication from microservice to microservice as it passes through the application. And you have to be authorized to be able to do that. So there's an entire built-in certificate capability that keeps everything according to Hoyle. And finally, and this is more the application developer's realm than anything else, support for circuit breaker patterning, which allows the application developer to control what happens when something goes wrong. If this service breaks, separate the code out into these two services and balance them 80% to 40% or 20%, those kinds of things. We call this traffic shaping, the ability to provide a specific level of service to a particular component of the microservices within your application, and to control the quality of that service to ensure that no one is getting starved and everyone is able to eat, which is, I hope, something we can continue to do in today's world. So the circuit breaker patterning itself allows you to determine whether traffic should be continued if a routed portion is not operating properly or not. And it's at the application developer's discretion. That also puts a great amount of required thought on how the flow should go in the event of some change in the workflow between microservices. In this modular service development, you can actually integrate across disparate teams, and as a result, everyone will be taking advantage of the same catalog of services through the discovery mechanism. This really helps to ensure that nobody goes far afield and put things into your application that are unique and that can only be accessed from where they are. But the service meshing capability really didn't develop all at once. It went through a series of different architectures as it was in development. The original one was called a library, and what it meant was that each one of the services were placed into a modular component of bits that was then injected directly into your container. Each container held onto an entire copy of all of the services that were able to be provided in the mesh. This made sure that each one of the containers had everything that it needed and was self-contained. But there are some downs to that, and I'll get into more of them as we go. But the primary one was that you had to change them out when you added a new feature or capability, and then you had to recompile your containers, which was a cumbersome chore. The next iteration of architecture for the service mesh became known as the node agent. This was kind of an advancement because the entire cluster that consisted of multiple nodes, each node would have its own agent, and each container or pod hosted on that node would take advantage of that agent as the proxy to redirect all of the traffic. This was an advancement because not every container needed to know everything about all the services available. However, if that node itself, the agent, went down, it meant you lost connection with all of the pods or containers sitting on that node. So we had a bit more work to do. The current iteration, and the one that's most prevalent in the market today, is called Sidecar. Sidecar is actually a separate container that mirrors the original container. So every container on a particular pod or in a particular node has its own sidecar container that acts as a proxy service, and all of the network traffic that's going to go into or out of that microservice container is going to go through that proxy to get there. This has multiple advantages, and I'll be going into a lot more of them as we go, but the primary one is that if it fails, it only affects that container, and you can spin up a new one, it spins up its own sidecar, and so on. Okay, so we started with Shmesh comps. Now we're going to go into the types of service architectures in a little more detail, or Shmesh arcs, as I call them. So let's take a look at what happens with the library. First of all, this is the oldest type, and companies like Twitter and Netflix got into this right from the beginning, and they had versions of these libraries they called Finagle and Ribbon and Hystrix. But the whole intention here was that it was the first way to be able to inject these services into a container to allow it to take advantage of the mesh. As I indicated earlier, it's a little more difficult to maintain. You have to recompile the thing if you add something new to each of the library components. And as you can see, application A has its own set of libraries talking to application B, and if application C talks to application B, it uses its own set of libraries, so there's a possibility for mismatch. This version control problem is probably something that people started thinking about alternative ways of doing it. Also, this wasn't very good at controlling demand between microservices and containers. So we progressed onto the node agent architecture, which is way easier to manage because you've only got one per node. So you can host 2,000 containers on a node, and you're only dealing with the one agent that it's going through. That can also become a bottleneck if you think about it, because the more containers you put onto it, the greater stress is going to go on that node agent. So companies like Linkerd and Conduit came to be, taking advantage of this node agent architecture in the second iteration of service mesh architectures. Each resource has sort of a shared memory pool within that node agent, and it has to allocate it separately for the individual microservices. All of the services were generally running in the same process space, so there was contention between them. And the work resource sharing became really, really important, which was better than the library model, but it left a bit to be desired in terms of performance capabilities. So now we've moved on to the sidecar architecture, and the first folks to accomplish those kind of things was an open source project called Istio. And in the Istio framework, and Aspen Mesh is the commercial version of the Istio framework, sidecars were deployed one adjacent to the other and acted as that proxy. It eliminated network-based attacks that could go through an individual node or take advantage of a library change that would inject something that could be malappropriated to access a container. They attempt to use best practices for security, so TLS throughout from entry into the service mesh to exit out of the cluster or pod back into the service mesh. And because of the inherently close nature of the sidecar to the container, there's very little opportunity for attack from the outside, which is, one of the major benefits. So let's take a bit of a comparative look at some of the service meshes that are out there, as I like to call them, shmesh comps. So these are the grouping of both open source offerings and commercial offerings that I've sort of focused on in this presentation to compare. And I'll be honest with you, I have now added 4 or 5 of these as I have done this service mesh presentation over the last 2 years, I think, as this has been developing. We're going to talk about Envoy, which is the foundation proxy for a lot of these implementations, and of course Istio, and the Linkerd and LinkerD2 because they came out with a new version. I'll focus more on the LinkerD2 as we go. There is a continuous mesh capability, and I'll give you some information about that. I spent a little bit of time with the gray matter folks. Gray matter is actually a mesh of meshes, perhaps, and includes some additional features that may not be in some of the others. And then from a commercial standpoint, Consul, Aspen Mesh, which is a commercial implementation of Istio, Kong, which is a highly developed project that goes beyond the extents of Kubernetes into bunches of other container orchestration methodologies. Of course, AWS has their own. I won't talk very much about that because they stole it from Istio, but that's okay. Superglue, in the same way that Istio is a mesh of meshes and continuous mesh is a mesh of meshes, allows you to control more than one from a single pane of glass. And finally, just because I wanted to be fair to everyone, VMware's Tanzu implementation of Kubernetes contains a service mesh, but it's founded on Istio as well. Okay, so those are the ones we're going to compare. And now let's break down the open source ones in those categories, the ops mesh. So this will give you a really good view of what a sidecar architecture looks like. It was originally a high performance application service written in C++ by the people from Lyft. It used that proxied architecture and was developed against the software oriented architectures of old. That's been around since I was playing in dirt. And the two greatest features was, of course, giving observability and allowing you to debug what was going on between microservices so you could recover easily from things. And the gRPC bridge remote procedure calls allowed you to use Python as a client, which was a big advancement from how they used to do it in libraries. But the biggest thing about it was developed directly for the performance of a proxy service. And there's very few moving parts. You've got the main threads, you've got the worker threads, and you've got the file flusher that makes sure that anything that's unnecessary, it throws out of RAM, since this sidecar methodology uses a little more memory than other methodologies. So this is Istio's implementation of that methodology. It's founded on Envoy as a proxy, but in the second iteration of development from Netflix, going from Helix and Ribbon, they decided the sidecar methodology would work out better. And they introduced circuit breaker technology, which allowed the application developer much more control. This one has more moving parts in it because it's doing more things. So the manager itself is the rules manager for policies and things that drive the Envoy proxy capabilities. The mixers allow for probes for the telemetry to be captured. And of course, authorization, Istio auth, allows in the control plane for service to service, TLS, and all of the encryption methodologies that keep things safe. The data plane is really thin. It's just a feature-rich Envoy proxy that they've sort of stripped everything else out that would have to handle anything like policy engine or any of those things. So that's the Istio sidecar architecture. LinkerD1 it could have been done in either a node agent or a sidecar architecture. Most of the time, I guess people had used the sidecar architecture and so they decided to rewrite that portion of it, which ended up being the LinkerD2 version. This is depicting the node agent side of this thing, which, as you can see, if the node 2 proxy goes, all of the application A, B, and C traffic that goes through it would stop processing from host 2. But it had a high degree of concurrency, and it could push things pretty fast, which is what really Linkerd, the initial iteration, was known for. Their sidecar implementation took what Istio had done with their mixer and control plane and sort of puts it on steroids. So you have a much higher level of control over various sections. And of course, it's gathering all of the various telemetries and everything else directly through the control plane as opposed to having a mixer that you could plug and play additional items into. And then once again, the data plane has its own proxy sidecar, but instead of using Envoy, they have written their own. And as the folks from the LinkerD2 group who I spoke with describe it, as opposed to Envoy, which is sort of using a Swiss Army knife to do proxying, this is like using a needle, a specific pin prick to accomplish the proxy process, which makes it really fast. Okay, so those were some of the open source offerings out there in the real world. Let's take a look at some of the packaged commercial offerings. Comms Shmesh. Okay, so Consul was one of the first, and it was developed in that node agent capability. Had very good service support, but its whole claim to fame was that you then didn't need a smart network at all. So switches and things like that had built-in features and capabilities for performing TLS and those kind of things could simply be thrown away, and you could use a dumb pipe with dumb switches and allow Consul to actually perform all those services for you. It stores all of its entries in key value pairs, which is a pretty typical database. etcd and things are used underlying to keep track of these things. And it was a pretty decent node agent architecture. But as you can see, if things went between host 1 and host 2, an agent on 1 died, you'd have trouble talking to host 2. The Aspen mesh is actually a repackaging of the Istio mixer manager auth with a layer on top that does an API service and all of the telemetry settings and all of those things. They built in canary testing, so you can do staging to production as a part of the Aspen mesh process. They have their own user interface that allows you to take a look-see at things from inside. And it's an isolated management platform that can provide its own service levels to anything underlying in the pod pools or clusters. And that, of course, you get enterprise level support from these folks in the same way that you would get enterprise level support for LinkerD2, for example, from Buoyant. Now, Kong is a completely different service mesh in itself. There's the need for incorporating other kinds of architectures like serverless and capabilities that extend beyond the Kubernetes framework as an orchestrator. And Kong allows you to do that. It not only handles HTTP traffic, but also things like TCP traffic and the ability to control what's going on and creating rules that extend out from beyond the Kubernetes framework itself. In doing that, of course, I think that Kong is probably going to be one of the first ones to adapt to HTTP3, which I don't know if you're aware of this, but when we move from the current version of HTTP to the next version, we're moving from TCP to UDP. Surprise, we're going to have to rewrite all of our tools to accomplish that. UDP's been around as long as I've been working in the industry, since the 80s, to do things like Oracle listeners and whatnot. Okay, AWS has what they call their own service mesh, but it's a me too. It's so they could do a checkbox to say, yes, I can offer you a service mesh if you run Kubernetes in my AWS EC2 environment. And it's really a repackaging, a brief repackaging of the Istio framework. Okay. Wanted to compare some of the features inside of service meshes, or comps shmesh. So, starting from the initial implementations, really, Envoy got a lot of things right. But as you'll notice, it relies on gRPC for remote procedure calls and HTTP2. So it's really just handling those two protocols. It's going to have to handle more of them here in the near future. There's an experimental version out there now that helps you do that. Their whole idea was speed and collection of metrics. Those were key, and those are still a very important part of it. Istio, for example, is added the security frameworks and policy generation and fault injection in terms of being able to do circuit breaker patterning and stuff like that. It handles pretty much the same stuff, plus the TCP traffic, which I think was an advancement. Nice policy and quotas and rate limiting so that you can control the quality of service, and it's multi-platform, and it will run sort of anywhere you can deploy a Kubernetes framework. So, some of the LinkerD2 features and Linker features, when they rewrote Linkerd they rewrote it from C, which was the original language, to Rust, which is a much more robust cloud-native language. And LinkerD2 is a whole lot faster than Linkerd, and they compare very favorably now with the Istio Envoy grouping in terms of performance. They're still catching up in terms of some features and capabilities that were in Linkerd that haven't quite yet made it to the LinkerD2 version. But here's their roadmap. And this I got because the folks from Linkerd were nice enough to sit down with me and explain this stuff. They're adding distributed, this was as of earlier this year. They did the auto injection, they did MTLS, they included Helm charts in the support matrix. In the next iteration, they're going to add multi-cluster. This is coming, by the way. There's an experimental version of Istio, for example, that handles more than one clusters using the same service mesh capability. And of course, there's MTLS enforced throughout. So from in-flight to at-rest support of encryption and the ability to expand the mesh and all of those kind of things to include new clusters. Okay. Consul was one of the original founders of this. It had some of the built-in features and capabilities, but there were, it considered itself self-contained. So HashiCorp decided that it would put into it everything you always wanted to know about service meshing. And as a result, it got rather bloated. Aspen Mesh took advantage of the Istio framework and kept it very simple so that from a single pane of glass, you can actually support all of the features and capabilities, including policy generation and all of those things. And the monitoring capability is sort of built in and focused on workflow traffic. The Kong Enterprise had an original change. They added this plugin deployment kit where by publishing their APIs, you could actually plug in different kinds of load balancers and stuff like that. It started with Nginx and Luau, but now it's come to a broader set of capabilities. They added Kuma. This was you'll notice the bullet points a little separated. That's because I found out about this when I talked to the Kong folks to update this presentation. So it's got circuit breaker capabilities and health checks boosted not only at layer 7 but at layer 4, which is where they should be. And of course, AWS has their own out there. But it's just a rehash of the Istio stuff that they charge you for, which is kind of sad. Okay, continuous mesh is started off with Traffic as their reverse proxy manager, which no one else is using. But it gives them some unique AI kinds of oriented capabilities built in. And it uses its own endpoints. So it's built external to the Kubernetes framework, which a lot of them rely on the framework that's there from a networking standpoint for their endpoints. Continuous mesh is self-contained in that way, handles the TCP traffic as well as the HTTP, provides load balancing and failover and all that circuit breaker and rate limiting stuff that we talked about being applied to service meshes. Super glue is that mesh of meshes. It handles multiple meshes. So you could use Envoy, you could use Istio, you could use LinkerD2 and things, and have this super glue control all of them from a centralized point. This is developing because people don't know which one to pick for themselves. Hopefully, by the end of this, you'll know which ones you may want to attack first and which ones you want to avoid, and you wouldn't need a mesh of meshes to manage that. So gray matter, I spent a little bit of time on the phone with these guys, and because it handles layer 3, 4, and 7 concurrently, of traffic, it has some features built into it that the others probably won't be able to attack. But at layer 3, you get the TCP level IP address connections and port designation management. And here you can get real true network segmentation out of it at the layer 3, which you can't get when you're dealing at application service layer 7. The layer 4 is really the protocols handling things going back and forth, checking discovery and health checks and observability built on top of the TCP/IP stack. And then layer 7 is the application service layer, so it's dealing with HTTP and web pages and all the other layer 7 actions that might be coming along. And of course, Tanzu, this is the VMware entry that relies basically on having a VMware infrastructure and NSX underlying your service mesh, and they built a plugin for it. Now, what that means is, of course, you are going to use VMware to do all of your hosting of things. Otherwise, this won't work. And although it uses Istio, they built this NSX plugin for it. So they're really kind of limiting the capabilities. But they built in some of the features that come with NSX. So if you're really VMware junkies, have at it. All right. This is why we invented service meshes, visualization. And so you can see what's going on inside of a service mesh or shmesh viz, as we like to call it. And all of them have very, very similar mechanisms for display. So almost all of them use Prometheus as an underlying storage mechanism for the data of the probes that they've implemented. Some have more probes than others built in, but generally speaking, they take advantage of Grafana as a visualization tool to access the Prometheus data and display it. Some, like Aspen Mesh, built their own on top of that to give you more specific information, but generally they all look like the darker image in the middle of your screen there. Performance is a big deal. Service mesh performance is very important, and so per shmesh, we need to take a look at some of these and figure them out. In terms of performance mesh measurements, there are these three categories of things. The first is going to be the control plane, and one, how fast you can deploy changes in it, the rate of configuration changes where you're adding policies and those kind of things. And then, of course, the number of proxies, how many containers you're actually putting out there, or if you're a node agent, how many nodes in your cluster. On the data plane side, the number of clients that you have to provide services to, the number of target requests, the request size and response size, number of proxies, protocols. So if you use things like UDP in addition to TCP, you're going to, and HTTP, you're going to put more stress on the data plane. How many CPU cores per node at that layer, and the types of proxies that they're going to have to filter. And at the bottom of the screen there, I've given you a couple of tools that are outside the realm of service mesh that you can put some real pressure on your service mesh to tell how well it's doing. Then, of course, the load balancing part of it is a very key aspect because this is going to give you the overall distribution of workflow through your microservices. And here we've compared these 5. And voila, Envoy became the key winner at the time I did this study of requests per second and all of that. It could handle a lot more than any of the others because they were actually mixing duty. They have more things to do than just handle requests. And even from a latency standpoint, the idea of latency doesn't hit until .99, and in all of these cases, and when it does hit, it affects Envoy less than the others. Now, LinkerD2 says that theirs is a smaller memory footprint and it's faster. And they're right. Their proxy service, the one they've written individually, is a bit faster and introduces less use of RAM to do what it does. And here's the study that they did to provide that. You notice they're comparing themselves to Istio, which I think is probably its major competitor. Istio has provided some of these in the 1.5 version of Istio. If you go to the documentation, they provide their own latency and number of connections, and you can see it's pretty darn fast, and that it will scale linearly and all of those kind of things. This is going to become really helpful when we go into multi-cluster, I think. And then if you really want to do deep dive into performance, I've given you some other places to look for statistics and comparison data. So now we come into the pros and cons of service meshes themselves, or pro-shmesh cons. Well, since I broke it down into these three categories of when we started with the library architecture, there really were some advantages. It was, self-service capability adoption for developers. You didn't need to go to anybody to find a load balancer and all those things. It was a way too tight coupling between the container and the services that they became reliant on each other. And that you could make them so that some would have some in one library and some would have another in a different library, so there was inconsistencies. The node agent architecture was way faster and less overhead. It scaled pretty well. Had a lot more useful deployments, so you had more statistics to go on, less monolithic. But there was only really vague support for encryption and things like that. If a proxy failed, boy, it took out a whole lot of things, and it wasn't transparent to the containers themselves. Whereas the sidecar architecture was really granular, so your encryption can be very unique, apply only to container A and not to container B. Added features and capabilities in a central location and observability within a central location. Resource consumption was spread, and the blast radius was one container. Of course, the disadvantage is that there's no real central coordination. It's going through the individual proxies. So you have to go out and coordinate it. The care and feeding is a little more difficult that way. And so it won't scale as easily. But the sidecar footprint itself takes up +1 space of a container with each container that it provides a proxy to. So, some final thoughts about this. I like Istio. We use it internally in my company, so that's just by way of giving you some idea of what we do. They did not become a member of the CNCF in 2019, and I was really sad about that. And they didn't fully open source the Istio trademarks. But I just read yesterday that the CEO of Google said, oh yeah, we'll eventually donate the whole thing to the open source project. So at some point, it's going to be considered a completely open source thing. Right now, the trademark of the name Istio still lies with Google. But Linkerd is already a member. They've been a member the entire time, and they have their own support organization in Buoyant that provides full business-oriented support. So where you'd go with Aspen Mesh to get that for Istio, you'd go with Buoyant to get it for Linkerd. There's a bunch of the open source ones available. Aspen Mesh is the best one as far as I can tell. And always, always, always base your use of a service mesh on the real world benefits you will receive from implementing it, because it's not easy and it's not quick. And you need to constantly evaluate how things are moving with it, because the world is moving very fast in this technology area. And as the bottom line to all of this smeshing that we've been doing, the service mesh is really going to become a mandatory part of things going forward. If you're not already involved in it, please take a look at it, because it's going to add so much to your orchestration of containers and implementation across clusters. Follow the technology. It's going to change every day. Every time I have gone back to this presentation, I have added 10 more slides to it, unfortunately. So you had to sit through this to get to this point. And there are some use case best practices that I've given you there. Please follow those, because they will help you to avoid problematic things. Now, I get to do a demo. I am hoping that I haven't put everyone to sleep by going through all of this. And yea, verily, I am going to vanquish the varlet with a bare bodkin by showing it to you in person. Is that okay?
Yeah, go ahead.
Okay. All right, guys. So I'm going to walk through this rather quickly now, so that I've got 10 minutes to sort of wrap this thing up for you. The first thing I'm going to do is I'm going to show you my underlying infrastructure. So I don't know if you know what Mirantis does, but we provide infrastructure as a service. This one happens to be OpenStack as the framework. This is my own personal account in this thing, and I've created a whole bunch of nodes to host things on. And you notice this UCP header in the front of it for some of them. Well, that's because I'm actually using Universal Control Plane, which is the Docker side of our house, to accomplish this. You'll notice that the OpenStack framework itself has to have performance measurements to it. This is part of what we do, as well as provide all of this observational at the operational level for it. But the key point of that is that we want to access the universal control plane of Docker to have created. Oh, and I'm showing the last part first. That's terrible. I was going to say these are my shared resources. These are my nodes. And those are the same as these. You get the idea. And within that, I've created a Kubernetes cluster that has all these namespaces, one of which is called book info, and one is Istio system. And within the book info realm, I've created an ingress, which is the Istio mesh gateway for book info. Now, what does book info do? Well, book info helps me to run book information that captures the data of how people feel about Shakespeare's plays. This one happens to be Comedy of Errors. It's a very funny play. In most of Shakespeare, somebody dies. In Comedy of Errors, nobody dies. And people recorded their feelings about that with black stars and red stars. And some people didn't like the stars at all, so they haven't recorded anything yet. Black stars, red stars, no stars, black stars, red stars, no stars, to keep track of what's going on with this Comedy of Errors play. Actually, I'm kidding. What's really happening there is I'm capturing what's going on in a service mesh. And you see this here? Those are the clicks I just did. And this was the status of how they went through the entire book info application service layer to get there. And if I want, I can actually trace what's going on inside of that service mesh. So that now you'll see it goes from the Istio gateway up the way through, and notice it stops here. This one's red stars. This one's blue star or black stars. That one's no stars. Why is that no stars? Well, because I've created a circuit breaker pattern that says if it's broken, don't let it go to the ratings, because that will cause a cascading failure in my application service. So stop here, don't go any further. But sometimes you actually have to trace more deeply than just how things are going and give me inputs and outputs. That's when I use things like Jaeger. Jaeger provides a set of captures of hotspots, those clicks, like the ones I just did, which were these. And if I need to, I can break down, oh, I had one warning there. What was going on? Oh, the spanner ID skipped clock skew adjustment. So it couldn't get from one point to the other fast enough. This one's a little more interesting. So this gives you all of the input and output information and which IP address and everything else. Now, why would I use that? Because I need to know how fast it goes from here to here to here to here, so that I could do changes, introduce changes that would improve that. Then I can look at how the mesh itself is handling that change in multiple different ways, from the workloads itself, like this, to all of these other performance metrics that I can keep track of, so that I can improve it here while it's being hosted on here. Now, I hope you've had an opportunity to sort of capture all of that information that I've given you today. If you didn't, I'm sure we're going to be handing the slides out and things of that nature. And at the end of it, I actually have my email address. So if you think of things after this that you'd like to chat with me about, you can. As I indicated before, Mirantis, my company, does this infrastructure services to provide software service delivery chains. And we actually have classes on Istio framework and things of that nature. And Vinayak, I think I can turn it back over to you.
Thanks. So let me quickly run through a couple of slides before we go to questions. I have some questions and we do have a few minutes left. So, this webinar is brought to you by Synerzip, and Synerzip, as you know, as the Agile Software Co-Development Partner, we accelerate your product roadmap using the latest and greatest in technologies like Kubernetes and microservices and all that. So can you advance one slide? So on this next slide, you're going to see a bunch of our customers. So here's a few of our customers. So just we have served to more than 200 customers over the last 15 years. So that's about us. And please advance to the next slide, Bruce. Yeah. So this is our next webinar. It's on Tuesday, the 19th of May. And the topic is API as a product, and the presenter is Rajiv Kaushik, who's a part of Code Connect product manager, FIS Global. So with that, let me turn our attention to questions, Bruce. So we have a couple of questions here. So, we talked about control plane and data plane. So can you just describe these two terms? I mean, we just got into it while describing the architecture, but what does control plane do and what does data plane do?
Sure, and this is a very good question. Thank you, Vinayak, for whoever asked that question of us out here. So in most application service layer where security is going to be fundamental, you have to segment out your traffic between two elements. The things that are controlling the flow of the information from one place to another, and the actual flow of data itself between components. So the control plane aspect is actually where all of the policy engines and all of the circuit breaker patterning and all of the load balancing decisions and things are made within the control plane. It is also the point where all the probes are able to access the speed and performance of individual clicks and things of that nature. That frees the data plane to just handle the flow of data traffic between microservices. And what that means is I can secure one from the other. So it was a vehicle for ensuring that separation of duties and to ensure that you could secure the traffic that's required with workflow in and workflow out of clusters.
Yeah. So thanks. The next question is about, what if we already have some of the existing service discovery part, which is managed by the sidecar and by the service mesh in there already with something like Eureka, or what if we have Asterix managing your timeouts and circuit breaker pattern. Now, do we have to bolt out those things to bolt in these things with Envoy and Istio or the service mesh, or so is this going to require some re-architecting, reconfiguration of our existing applications which we have built?
I would think first and foremost, it really doesn't require re-architecture so much as a rethinking of the workflow that's going to happen. You could take a container that was written for your application service, and as long as you're not injecting things into the container to say, go use this alternative, if you just place that container in a pod that is using the sidecar architecture, it would redirect the flow automatically so that you wouldn't really have to tell your container that you've changed anything, but it would reapply all of the capabilities for discovery and circuit breaker patterning without any change at all.
Right. So that makes it so. So what happens to managed services? So let's say I have some containers and some pods in which I'll be able to put sidecars, but these days I use a whole lot of managed services, and I need to do I need to have circuit breaker, for example. If a service that is external times out, I need to have a circuit breaker pattern there. So what happens to managed services, and also what happens to lambdas, the serverless functions? I mean, does everything have to be sitting in containers in Kubernetes, or do service meshes also address lambdas for serverless and also managed services?
Right, another good question. Thank you very much. So Istio currently only addresses within the Kubernetes cluster but they allow you to say pod A, which is application A, basically deployment A, is under the Istio service mesh, and pod B is not. So you could have two different types of containers in the same cluster, some being managed by a service mesh and others not, using Istio. However, some of the others, Gray Matter, for example, or Kong, actually handle applications external to the Kubernetes framework. They're dealing at the TCP layer at layers 3 and 4, in addition to layer 7. So those you could actually do your managed services external to Kubernetes and your Kubernetes services using the same frameworks.
All right, thank you. So, this was wonderful. Thanks a lot, Bruce. And we are right over 1 hour now. So thanks a lot for the audience for your questions and participation. And
Thanks, guys.
Bruce.
Thanks, Vinayak. I'm very pleased to have been able to do this with you. Thanks,